In this chapter, we're going to talk about different types of circuits. First, we'll discuss series circuits and then parallel circuits, and then we're going to combine them into combination circuits. So let's get started. The definition for a series circuit is one in which current passes through each device, one right after another. And you can think of this as everything is connected in one loop. For our voltage, the voltage that comes from a source is going to be the sum of the voltage drops across each of the objects that are in our circuit. And when we talk about the term a voltage drop, that is referring to an electric potential difference from one part of a circuit to another part of a circuit. So as an example, I drew you a picture of a schematic diagram with a voltage source, which would be my batteries, and two light bulbs in series with each other. So notice that everything's in one continuous loop. Now for the voltage, let's say that I've got 6 volts total for my batteries. Well, there would be an electric potential difference of 3 volts across from one end of a light bulb to the next, and then from one end to the next part of the light bulb, there would be another voltage drop or electric potential difference of 3 volts. Notice that these two added together are going to equal whatever the voltage is that comes from my source or my battery. Now, if we were to look at different resistors or objects that provide resistance in a series circuit, we have what's called the equivalent resistance, and it's really simple. We just simply take each individual resistance and add those together to get our equivalent. And as for the current in a series circuit has the same current everywhere traveling throughout the circuit, and we can find that by the equation of Ohm's law, but we're going to rearrange and tweak it just a little bit. So the voltage that we're referring to would be what comes from the battery or our source, and then the resistance in the equation would be our equivalent resistance to make sure that you take into account every item that's in the circuit. And then remember that resistance will be measured in ohms and current in amps. So we have an example problem. You are not required to draw a schematic diagram, but I find sometimes that it's helpful, so I'm going to go ahead and draw out that picture for you. So you would have a battery, and in this case, our battery is 120 volts, and then we've got 3 resistors that are connected in series, so all 3 of those resistors are in the same loop. I'm going to go ahead and label those. We've got 330 ohms, 560 ohms, and 220 ohms. You are asked to simply calculate the equivalent resistance of the circuit. So all we're going to do to get that equivalent is add each of those individual resistances together. So go ahead and plug those numbers and come up with your answer. You should get an equivalent resistance of 1,110 ohms. And it really is that simple. So if you ever see a series circuit, you just simply add all the resistances together to get the equivalent. For example number 2, I'm going to set up a schematic diagram for you, and you calculate the equivalent resistance. So remember, on your schematic you have some options. For the battery, it doesn't tell you how many batteries. You can draw 2 or 3 as your representation, but this would be your voltage source, and we have 130 volts. And then we're told that there are 2 68 ohm resistors and 2 33 ohm resistors. We're not told an order for those to go in, and it really doesn't matter as long as they're all in the same loop, because that would indicate that they are connected in series with each other. So you can mix and match those, because when we find the equivalent, it does not matter what order you add numbers, you're still going to get the same answer. So go ahead and pause the video and find the equivalent resistance and come back and check your answer. Okay, since we have 4 resistors, I'm going to end up adding all 4 of those together, and you should have got an equivalent resistance value of 202 ohms. Now that we have an idea of how to calculate an equivalent resistance, we're going to take it a step further and work with the current and the voltage in the same type of problem. So we've got 2 resistors connected in series across a battery. So I have my variables listed, and I went ahead and drew a schematic diagram for you as well. So if you want to take a moment and list that and draw a schematic, that's a helpful visual representation. Now in part A, we're asked to find the current in the circuit. So remember, a series circuit has the same current all the way around. And in order to find the current in a series circuit, I'm going to use that formula we talked about at the beginning. We know how much our voltage source is, but we don't know the equivalent resistance, so we need to find that first. So we know we're given two resistors, so I'm going to plug those in and find the equivalent, which happens to be 129 ohms, and then I can use that value to plug into my equation. So my voltage source was 45 volts, my equivalent resistance was 129, and all I have to do is divide those numbers to get the current. And you should come up with an answer of about 0.349 amps. Next, we're asked to find how much voltage drop there is across each resistor. So remember that voltage A and voltage B are going to equal our source, so we know they're going to total up to 45 volts, but we want to know how much of those 45 volts goes across the first resistor and how much across the second resistor. So a helpful reminder in solving this is that in a series circuit, the current is the same everywhere in the circuit. So each of those resistors has the 0.349 amps from part A flowing through each of those. So we can use that information and Ohm's law to find out how much voltage is in each one. So to find out how much voltage drop there is across resistor A, I'm going to multiply that current times the number of resistor A itself. So we would simply plug in those values. So our current was 0.349 and resistor A had a value of 47 ohms. And when we multiply those together, that tells us that there's 16 volts in that part of my circuit. So if we think about our schematic diagram, out of the 45 volts total, 16 of them are being used up across resistor A. We also need to find out how many are used across resistor B. So we can do this one of two ways. You can probably figure out that since the voltage source is equal to voltage A plus voltage B, we can simply plug in our original 45 volts and then the 16 volts that we found. And then that would give us the difference as how much voltage drop there is across resistor B. So we would double check and see that 29 and 16 do in fact add up to our 45 volts. Or we could have used Ohm's law again and calculated just like we did for the first part. You get the same answer either way. So on your test, you'll have a couple of options like this one. Now we're asked to look at if we take that 47 ohm resistor and we're going to replace it with one that has a little bit lower resistance if the current increases, decreases, or remains the same. So we're not really changing our battery, but if we think about Ohm's law, the current and the resistance should be inversely related to each other. So if we're making that resistance smaller, we should see an increase in the current. And I'm going to walk you through mathematically how we can verify that. So first, remember to find a new equivalent resistance with that new resistor A. So we're going to plug those numbers in. So we've replaced our 47 ohms now with 39, and that gives us a new equivalent of 121 ohms. From there, we can go back to the formula we used earlier, where we take the voltage source and divide it by the equivalent resistance, and we're substituting in that new equivalent R, and our 45 volts from the source remain the same. And then once you plug those in, you should see that we get a value of 0.372 amps. And when we compare that to the answer from part A, we do see that the current does in fact increase. And then now to find our new voltage drop across the 82 ohm resistor, remember that's the one that we kept constant, we're going to use Ohm's law. So we'll say the voltage drop across resistor B is going to be the current, which is our new current, times resistor B. So plug those values in and see what you get. You should have come up with 31 volts, and that does tell us that the voltage drop across that resistor also increases. That's it for today, and next time we'll discuss parallel circuits.